Hello and welcome. In this video, we're going to look at how to apply Ohm's law to our parallel current expectations. So in this example, it says, what is the total current in the following circuit when the voltage source is 9 volts, the R1 resistor is 94 ohms, and the R2 resistor is 72 ohms? Right? So they want total current, which means it's the current at the very beginning entering the junction node, IT. We also have two other currents in this circuit, right? We have I1 and I2. Right? And we know that if we were to sum those two currents together, we would end up with our total current. And that's what KCL says. It says that we can add up our branch currents to identify the total current. We can also go for our total resistance. We can say that if we find RT, we can use that to solve out for our total current in the circuit using Ohm's law. Right? So there's two pathways for this, and both of them will get us the same answer. We can focus on getting the branch currents, adding them together, and getting back over to our total current that way. Or we can use our total resistance, RT. So let's do our total resistance. We'll say that we have a need to get I out of it. So we'll say that the current is equal to the voltage source divided by the resistance total. And that's going to get us that total current, IT. So let's solve for our total resistance, RT. Since that's a parallel connection here, we see that RT branches here. We have an R1 value in parallel with an R2 value. So we'll say that that's R1 in parallel with R2. And we can plug that into our Desmos calculator over here using our parallel equation, 1 over 1 over. We'll say 94 is our first resistor plus 1 over our second resistor of 71. So we get a total resistance of 40.4 ohms. We'll divide that by our voltage source of 9 volts, and that's going to be our total current, IT, will equal, we'll calculate that out. We'll say that we have 9 divided by the previous answer that we just got, that 40.4, and that's going to give us this value, this 222 value. So it's stated at 0.222 amps. We can move that into milliamps if we wanted to. We can say that IT is also equal to, move it over 1, 2, 3 to the -3 location. That way we can put our M on there. So it's 222 milliamps. All right, let us know if you have any questions.